Now we are going to discuss 2026 January Chemistry Unit 4 paper. Let's go question by question. This question says, the graph shows how the concentration of reactant changes with the time as reaction proceeds. They're asking what is the half-life of this reaction in seconds. Half-life means, let's assume you take a concentration C. Okay. The time which takes to make that concentration C to is half of its original value. So the concentration C is 0.005. You can take any point. So I'll take C as 0.005. Then you have to take half of it. So that means C divided by 2. So half of it comes 0.005 divided by 2. That means 0.0025. Okay, this is the point which I get 0.0025. So if I take the value, so 0.005 which starts at the time of 0 seconds, and when it becomes 0.0025, okay, so its time is somewhere here. So we can see that one box is equal to 10, 50, 60, 70, 80, 90, 100. So it's simply between 0 to when it becomes 70th second, so 0 to 70, which is 70 seconds, what will happen? The initial concentration becomes half of its original value. So therefore half-life time of this reaction is 70 seconds. So for answer for question number 1, part A is C for me. Right. Let's go for part B. There's another section in this question. Which graph shows how the rate change with reactant concentration in this reaction? Right. So to identify how the rate and the reactant concentration change, we have to identify another thing. So there's something called half-life time. We know that we measure the first half-life time. So the first half-life time is its concentration is there, and its concentration to become half of its original value. So it took 70 seconds. Okay, that's what we found. Then we have to find the second half-life time. What is second half-life time? Where you stopped finding the first half-life time. Okay, take that concentration. I'll call it C dash. Check the time which is going to take half of its original value. Half of its original value means this is 0.0025. Half of its original value is 0.00125 because C dash half. Where you get C dash half, 0.00125, it's somewhere here. Okay. So when I check that time, again 70 to 140. 70 to 140 difference again is 70 seconds. If you have constant half-life time, if you check this concentration versus time graph, if the half-life time is a fixed value, we call it is a first order reaction. So first order is something like this. First order means order with respective to the concentration of reactant is 1. So which means if you write the rate expression, rate law for this one is simply say that rate equals rate constant time concentration of the reactant to the power 1. That's what we call it first order reaction. Okay, let's use that one to answer our second question, part B. Which graph shows the rate changes when the reactant concentration for this reaction? So we know the rate law when the reaction is first order. Rate equals, we just wrote it, rate constant time concentration of reactant to the power 1. So what will happen if the concentration of reactant, if I double it? If I double the concentration of reactants. Now I have 2 concentration, 2C. That means concentration of reactants multiplied by 2. Right. So 2 to the power 1. So when you double the concentration, since this is a constant, what will happen to our rate? this side also should doubles. So it will become 2R. So when the concentration doubles, rate also doubles. So if this is rate concentration is C, let's assume rate is R. When you double C, the rate has to be also double. So that means we are talking about a linear relationship. So that means it's a directly proportional to each other. So as a result of that, my answer for question number 1 part B is B, because in this straight line only, when you double the concentration, what will happen? Rate will also doubles. Right. Question number 2. Which measurement could be used to obtain rate data for a reaction shown? Okay, we are going to find a rate of this reaction. Rate means how fast a given reaction will take place. How do you measure the rate of a reaction? Is simply you can find change in concentration of either reactants or product over time taken. That's how we can find how fast the reaction take place within a given period of time. How fast reaction take place. How we can measure the change? Okay. Can we measure the color intensity? Yes, we can, because iodine has a color. Iodine is a purple gas. But if you take hydrogen iodide, it's a colorless gas. Our purple color turns into colorless. How fast your purple color disappears tells us how fast iodine get used up. So that can be used as a reading for reaction rate. pH value. pH value you can use, but the thing is here hydrogen iodide is a gas. pH we can easily find in aqueous solutions. Since it's not an aqueous solution, this pH finding pH value for this reaction is not a practical thing. So we can't do it. Pressure in a fixed volume. But pressure for gaseous reaction, yes, that's a good idea. But the thing is, when you're trying to measure the pressure of this reaction, hydrogen gas reacts with iodine gas. How many moles of gas are there in the reactant side? 2 moles. Gives you 2 hydrogen iodide gas. How many moles of products are there here also? 2 moles. So that means during the reaction, the number of moles of gas doesn't change. So we can assume that pressure also remains unchanged. So therefore, this is also not an easy way to find it, and it's impossible. Like, you can call it impossible because number of moles for any gas is almost fixed. They have a slight difference because of their intermolecular forces, but the number of moles and their volume is almost the same. So therefore, pressure change is either negligible. In your level, you can see that you can't measure that pressure change. That's possible. So therefore, our answer for question number 2, answer C, we can't accept it. We have to reject that answer also. D, volume at a fixed pressure. Yes, same thing. The volume change is negligible. So therefore, you can see that there is no volume change because the number of moles are same. So since B is not our answer, C is not our answer, D is not our answer. So therefore, answer for question number 2 is A. Right. Let's move on to question number 3. The rate equation for the hydrolysis of halogenoalkane is shown. Which row is correct? Oh, there's a halogenoalkane. Right. If you take this halogenoalkane, so this is our halogenoalkane, carbon atom is there. There's a bromine atom and hydrogen atom. There are 2 CH3 groups. One here, another one here. What is this halogenoalkane? That's the first question they're asking. First section. So when you look at this halogenoalkane, there's halogen atom. It attached to the carbon atom, check how many R group. R groups means other than hydrogen, how many alkyl groups are there. So we have one alkyl group here. This is one. Another alkyl group here. There are 2. If we have 2 alkyl group attached to the carbon atom where halogen is attached, we call it secondary. If you have 1 alkyl group, primary. If you have 3 alkyl groups, we call it tertiary. So this is secondary. Now we have 2 options, either C or D. And you can see that when you look at the rate law, if you don't see a number, that means it's number 1. So during the reaction, the total order means you add all the orders together. There's OH minus sign also there, but it is order with respect to OH minus sign is 0. We know that anything to the power 0 is 1. That's why that's not represented here. So we can see that if you take the total order of this reaction, if you add them together, you can simply see that is 1. The total order is 1. If the total order is 1, we call it is a substitution of nucleophile. If you take this mechanism, is a substitution of a nucleophile where total order is 1. That's why we call it SN1. S means substitution, N means nucleophile where the total order is 1. That's why we call it SN1 reaction. So when you look at this one is 1. So I call it this is SN1 mechanism. So therefore answer for question number 3 is C. Right. Then we'll go for question number 4. Before going for question number 4, in this one I know many students have doubts in these mechanisms. If you want to like a video to explain this mechanism, how they link with this rate law, just leave a comment below. Then I'll create a different video on this rate equation and the mechanism and discuss about these orders. Right. Question number 4, part A. A two-step reaction is shown. What is the role of I minus ion in the overall reaction? Okay, let's see about this reaction. So when they say a reaction is a two-step reaction, H2O2 reacts with I minus gives you H2O plus OI minus. There's another one. H2, second step is H2O2 reacts with OI minus gives you H2O plus O2 plus I minus. Right. If you want to get the overall reaction, first what you have to do is you have to add these two reactions together. So I'll add them, H2O2 plus H2O2. It becomes 2H2O2. I minus is there and here also I minus. If you have reactants and product side the same, so you can cancel them also. So I minus cancels out, right? Then if you take OI minus and OI minus, they also cancel out each other. So then only H2O2 on this side. Let's see what comes on the product side. If you go to the product side, H2O plus H2, it will be 2H2O plus O2. So you can clearly see that the I minus sign enters the reaction and leaves out the reaction without being used up. Anything enters the reaction and leaves out the reaction without being used up, we call them catalysts. So I minus sign is a catalyst. And we know that when you add I minus sign, the rate of reaction is also fast. So it's a catalyst. Then they are asking adding another word, heterogeneous or homogeneous. Homo means same. The meaning of homo means same. Hetero means different. So same means you look at the reactants physical state, it aqueous. And the I minus sign is also aqueous. So you can see all the reactants and products, they are in the aqueous. Most of the reactants are in the aqueous form. And our catalyst also in the aqueous form. If reactants and catalysts are in the same physical state, we call it homogeneous catalysis. So therefore question number 4, our answer for part A is B. I minus sign is a homogeneous catalysis. Let's go for part B. Part B say that which is the equation for the oral reaction. We just found it, no? We just wrote the equation for the oral reaction. When you add them together, we got 2H2O reacts giving you 2H2O plus O2. 2H2O2 gives you 2H2O plus O2. So it's simply a decomposition reaction. So therefore question number 4, part B, our answer is C. Okay. Now let's go for question number 5. Which expression relates entropy and equilibrium constant? Okay, so this is a direct question because this equation we have learned it. So simply the equation for this one is delta S total equals R, L and K. So therefore we can remove the answers with minus sign, and this is not delta system. Delta system equation is different. Delta system is equation is simply products minus reactants, and delta S total is RL and K. This is our equation. You might be thinking, how can I remember all this stuff? So don't worry, at the end of this video I'll add a small part how you can remember what are the techniques that you can use to memorize things easily. So but at the moment, for question number 5, our answer is B. It's a straightforward theory question. Right. Let's go for question number 6. What is the equation for the first electron affinity of sulfur? First electron affinity means is the enthalpy change when 1 mole of gaseous element, 1 mole of gaseous atoms takes 1 mole of electrons in order to form 1 mole of uninegative gaseous ions under standard condition. If I repeat it again, is the enthalpy change when 1 mole of gaseous atoms, here 1 mole of gaseous atoms, take 1 mole of electrons to produce 1 mole of uninegative gaseous ion. So this is the first electron affinity of any element. For sulfur, is 1 mole of sulfur gaseous atoms, take 1 mole of electrons, form 1 mole of S minus gaseous ions. So we have, they are asking the equation for the first electron affinity. We have 4 answers. Out of these 4 answers, B is the one which represent this scenario. So therefore answer for question number 6 is B. Now let's go for question number 7. Which ionic compound would be predicted to have the least exothermic lattice energy? Right. So remember this part, right? This is a relationship that you have remember. Lattice energy, I'll call it LE, is directly proportional to the charge of the anions. So I just write it in words. So charge of the ions, charge of ions. It can be anion as well as a cations. But it is inversely, like, so directly proportional this, but in inverse proportional to the size of the ions, size or radius. So we call it size of ions. So in one word, if I tell you, is something like this. Let's assume you have higher charge. It might be cation or anion, anything, right? So if you have greater charge, what will happen? Lattice energy is greater. Why is that? Because charge and lattice energy are directly proportional. But if you have lower charge, then directly proportional lattice energy will be lower. But inversely proportional means things are different. If the sizes are big, so let's take you have large iron. So when the size of the iron is high, what will happen? The effect is inversely. That means if the iron is large, lattice energy will show the opposite movement. That means lattice energy will decrease. And the same way, if you take small iron, if you have small ions, then it will be opposite. Lattice energy will increase. Okay, these are the 4 points you have to remember. Okay, assume that bonding is 100% ionic. So that means they say that don't think about extent of covalency. Let's see what we are talking about here. First one is calcium sulfide. I'm talking about calcium 2 plus, and calcium is a group 2 element, and a sulfide ion which is a group 6. So calcium 2 plus and S2 minus ions are the ions involved there. Lithium fluoride, we have lithium plus ion and F minus ion. Magnesium oxide, we have Mg2 plus ion and O2 minus ion. Sodium chloride, we have Na plus ion and Cl minus ion. They're asking least lattice energy. Always lattice energy values are exothermic, so therefore asking least lattice energy. Obviously, we know that charge is high. We learn from here. If greater the charge, lattice energy is greater. So I have to remove all the answers with greater charge ions. Calcium 2 plus S2 minus ions, Mg2 plus O2 minus ion. I just removed them. So I left out with answer B and D. Then they're asking the smallest least one. You get least lattice energy when the ion is the largest one. Okay, we'll find the size of the ion. Lithium has only 3, its atomic number is 3. So it has only 3 electrons. And when it becomes lithium plus, it has only 2 electrons. Sodium has 11 electrons. And when it becomes sodium plus, it has 10, but it's greater number of electrons. So it will be large ion. Fluorine has only 9 electrons. When it becomes fluoride, it will have 10 electrons. But chlorine has 17 electrons. When it becomes chloride ion, it will have 18 electrons. So I remove the high charge one. Now I want the least lattice energy. Least lattice energy comes when the ion is the largest one. So largest one out of lithium fluoride and sodium chloride is sodium chloride is the largest one. So least charge, largest ion will give me the least lattice energy. So therefore my answer for question number 7 is D. Right. Let's go for question number 8. Question number 8 has, yes, 2 parts. The equation for a reversible reaction is shown. What is the Kc expression for this reaction? It's so easy. So when you write the Kc expression, you have to write the concentration of the products. We know that for Kc expression, you can write it for liquids and gases both. But solid we can't include in the Kc expression. So my product is NOBr. Then you put the stoichiometric value, or we call it mole ratio as the power, NOBr to the power 2, divided by reactants are NO gas is there, molar ratio is 2 to the power 2, times Br2, molar ratio is 1 to the power 1. So let's see where we have this answer. So if you look at this one, question number 8, if you see C, yes, we have that answer. So answer for question number 8A, section A is C. Right. Now let's go for second part of this question. In part 2, they are saying that, okay, now we know that the answer is C, right? So we just remove the other parts. We don't need the answers. We know that C is the answer. So I know the equation. Now I know is Kc value. Which row shows the change that occurs when the temperature is decreased. Okay, temperature is decreased. Now we have to learn a little bit our AS level knowledge also. So this is a equilibrium, a reversible reaction. So in this reaction is in equilibrium. Now we are decreasing temperature. Temperature is outside, temperature is low. We learn that in AS level, usually when the system is in a dynamic equilibrium, they will counter react against the change. What is the change? You decrease the temperature. So what the dynamics equilibrium will try to do? Increase the temperature. To increase the temperature, it has to give out heat. So it has to give out heat. Giving out heat, we call it exothermic reaction. So it has to perform the exothermic reaction. Luckily, our forward reaction is enthalpy change is minus, negative value. Forward reaction enthalpy change is negative means exothermic reactions have negative enthalpies. That means forward reaction is the one it will take more and more. It will perform more and more forward reaction. Why? Forward reaction is exothermic. How do I know it? Its enthalpy change is negative. So when the more and more forward reaction take place, when the temperature is decreasing, because temperature is decreasing, so you have to increase the temperature, you have to give out heat. So more and more forward reaction will take place. So therefore what will happen? When it happens, what will happen to the yield of NOBr? Because in the second column, they are talking about yield of NOBr. Obviously, when more and more forward reaction take place, yield of NOBr increases. So there are two answers where NOBr concerned yield increases. Then what will happen to the Kc value? When the NOBr value increases means the numerator is increasing. We know that in a fraction, when the numerator increases means Kc value also increases. So my Kc value should increase. So both NOBR and value of Kc should increase. So therefore, if we go for question number 8b, answer is A. So now we discuss half of the MCQ paper, unit 4. And now I'll tell you, now in unit 4, unit 5, there are a lot of things to remember and understand. So it's really a little bit difficult for you in this time to like remember all this stuff. But if you understand how your brain works, you will be able to find the patterns. For an example, first you have to identify how the brain works. So you can simply look at this picture and see what you can see inside that picture. So some of you might see, when you keep on looking at it, you can see a dog, some might see it as a cow in this part of the picture. Some of you might see a tree here. Or some might see a different, it might be anything. You can see a human face here. Yeah, you can see this here, 2 specks, and there's the hair, and you can see a human face. So you will see different stuff in this one, but this picture has no meaning. It's just a little bit black ink on a white surface, that's all. But you start seeing things when you look at this picture. That's how the human brain works. When you see something which is meaningless, what your brain try to do is make something meaningful. It always try to create an image with some meaning. That's the first thing you have to remember. Our brain always like to work with images, visuals. Okay. Let's go for second thing, what we have to understand about our brain. Okay, let's assume someone asks what is the 7th letter of the alphabet. 7th is 2 is easy, no? You go for this one. What is the 16th letter of the alphabet? So how do you remember it? You just go through it. You just sing the rhyme, no? A, B, C, D, likewise, you keep on singing the rhyme. So when you sing the rhyme, you will be able to find the 16th letter. I'm not going to tell you what is the 16th letter or 7th letter in the alphabet. But imagine you can remember that rhyme. So if you are 18 years now, you learn this rhyme almost 14 or 15 years ago. Something you learned 14 years ago, still you can remember. Why? Human brain always like to remember things which are when they are in the rhymes. So first thing is, human brain likes visuals and human brain likes rhymes. Next one. Okay, I have a picture of a lime here. So what I want you to do is close your eyes. Now imagine this lime on top of your palm. And what you are going to do is, you are going to take this lime and you are going to have a bite from it. You are going to bite the lime. Just imagine this. You get the feeling, right? You get the feeling, that taste of the lime, and that your nerves and everything, you get that feeling in your brain. So the third thing you have to remember is, feeling is something which you can remember. Your brain remembers them very well. So these are 3 things you have to understand. If you want to learn something, if you don't want to forget them, you have to put them into pictures, sounds and feeling. I'll tell you what are things you can do. For an example, you take the first one, picturing. Now imagine I'm asking something from biology. If I tell the word human heart, now imagine what comes to your mind. Is it a phrase or sentence of the human heart, or the picture of human heart where you have seen in your books or when you are doing the lesson or somewhere? You get the picture, right? So that means if you can put something into a picture, you will be able to remember it. For an example, if I want to remember the reactions of copper, what I do is, I have made charts like this. Balancing equation, we can do it. First we have to know what is the reactant, what is the reagent we are going to add, what is our product, and what is the color. So what you can do is, you can make chart like this and paste them on your walls. Wherever you are, like on your walls in your room, you can paste them. So each day early in the morning, you wake up and you read the walls of your room. So when the exam time comes, you don't have to remember like large amount of pages and books and everything. You have to only remember the walls of your room. So if you keep on practicing this one, a room is a place where you spend most of your time. So the walls of your room will come to your mind. So you don't have to put much effort to remember these colors and these reactions. That's how you can use picturing if you want to study well. Second thing is, let's see sounds. There are things we have to remember and everything. So there are like, so you can create your own rhyme. So this is like very common rhyme you can find in the internet. You can use any your friends. It can be something which is unique for you, your friends, and something that you use to tell. For an example is, please stop calling me a careless zebra. So it tells you the reactor series. Please means potassium, stop means sodium, calling means calcium, me means magnesium, aluminium, careless, carbon, zebra is zinc. So likewise, you can remember this element by making your own rhyme. You can make your own rhyme using any word. Then the last one is feeling. How can you do this feeling part? The best thing is, now when I'm talking about, let's say nickel 2 plus ion with sodium hydroxide forms a precipitate. Remembering these reactions and colors is not an easy task. Instead of that, what you can do is, when you're talking about reaction, go to YouTube, or if you are in school laboratory, you can do this laboratory test and see how really nickel 2 plus ion solution look like. See how really this nickel hydroxide precipitate looks like. So that means you are going to like see it, you can touch it. If you are doing in the laboratory, you can see it and you can touch it. But if you are in the YouTube, if you're doing it from YouTube or internet, you can see these pictures. So as a result of that, you can get that theoretical concept into a feeling. So that's also increase the memory power. So if you can put these three things when you're studying in the future, then it will be the perfect way where you can remember all these reactions. Okay, so if you have any doubts, what you have to do is you have to just comment. I'll come up with another new video. And if you want to find the second part of this unit 4 MCQ discussion, you can simply visit the channel and you can keep it subscribed. Then what will happen, whenever I upload a new video, that you will get notified. Thank you.